So now that we have an understanding of how we can translate from words into mathematical expressions, we can now try to apply that to solving word problems. Yay! All right, so solving an application problem, first step, read the problem at least once. You might have to read it more than once, or 3 or 4 times. Read as many times as you need. Number 2, assign variables to the unknown quantities. So if you have one unknown quantity or 2 or 3 or whatever, try to assign a variable, usually x, and see if there's some relationships going on. So we're going to explore that more in the next section, but for now, make sure you assign those variables. Then you should be able to compose all of that into an equation. Now, a lot of these are going to be nice in the fact that you can directly translate them into mathematical expressions and equations, but not always, and you have to do a little bit of thought in some cases. So we'll see some of those examples. Once you have your equation, then you can solve it. And then, of course, since they're word problems, there's usually some context that is implied in the problem. So there might be talking about books or trees or people or something like that. So make sure you label things. Labeling is something I can be a stickler about. So definitely don't forget your labels. And then, of course, if you really are not feeling confident about it, you can always check your answer and make sure that it makes sense. So let's try a few problems. So looking at example 2, we got to translate the sentence, each sentence into an equation and solve it. Find the number. So if 4 times a number is decreased by 2, the result is 26. Find the number. Now this is a nice one in that we can compartmentalize the translations and then eventually synthesize it all into an equation. So we should know that 4 times a number is our 4x. So 4 times a number is decreased by, so we know decreased is subtraction, and then the 2, and then the result is 26. And we actually have our equation right there. So 4x minus 2 equals 26. The hardest part of all of these problems is always going to be just to get that initial equation set up correctly. Once you have that, it's not always easy, but usually it's a lot easier to solve the equation and break it down to find out what x is. So hopefully that's the case for you. But now for this one, we're trying to get x by itself, so we know we should get rid of the 2 first because it's subtracted off. So we're going to do the opposite and add it. And then we add 2 to the other side, that gives us 28. Now we can get rid of the 4 by dividing by it. So x equals 7. So 7 is the number. Dun, 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 dun. All right, let's try a few more. So if the product of some number in 5 is increased by 12, the result is 7 times the number. Find the number. Okay, so remember, product. Product is multiplication. So they want you to multiply some number and 5. So all of this is equal to x times 5, or we can flip it around and say it's 5x, because remember, multiplication is commutative. Is increased by, we know that that's plus, and our 12, the result is 7 times the number. So that should be all of the different pieces identified and translated. So let's put it all together. So we got 5x plus 12 equals 7x. So if we want to solve this one, let's get all of our x's over to the other side. Remember, always try to move the smaller value or the smaller term of x. In this case, which the 5x is smaller than 7x. So let's move that. It just avoids those negatives, remember. And then now we can get rid of the 2 by dividing it. So So x equals 6, so 6 is the number. Period. All right. Okay, let's try one more of these, and I think you'll have them down, right? So when 3 times a number is subtracted from 30, the result is 2 plus the number. Okay, so we got a little bit of going on here. We got 3 times a number, which is 3x, subtracted from 30. The result is 2 plus the number. Now, if you translated it like this, you are not correct, because what is wrong with this? Remember, subtracted from is reversed. It's reversed subtraction, so we got to flip-flop those two pieces. So our equation should be 30 minus 3x equals 2 plus x. Very easy to make that mistake, so just be careful. You've got to know those key phrases that flip-flop that subtraction. It's really the only one you got to worry about. Okay, we have our equation. Let's solve it. Now, we have a lot of choices from which we can pick a way to get this ball rolling. Now, usually we like to start with the variables versus the numbers. It doesn't really matter though. And we also like to start with the smaller of the two. Now, technically, -3 is smaller than +1. So I'm going to move this minus 3x by adding 3x. So that wipes those out. So we got 2 plus 4x, because we had to add the 1 and the 3. And so now we're on the home stretch. Let's subtract the 2. And then let's divide by the 4. And so x equals 7. So 7 is the number. Yay! All right. Okay, enough. So now that we have that, we are good. Now, as far as checking, we didn't check any of these problems, but we can always plug it back into the original equation to make sure it makes sense. So if I said 30 minus 7 times 3, which is 21, so 30 minus 21 is 9. What happens when I add 2 plus 7? I get 9. So it does check. All right. So that's the idea with this stuff. All right. So we'll stop there, and we will pick up more in the next video.